So this is 38, and 38 is a problem that I don't personally like because it's the answer. I have a hard time reconciling the correct answer in my brain. And I guess I just haven't done enough of that to get comfortable with it. But this is Bayes' theorem. I'd be surprised if this was in your standards. I haven't actually planned out our stat stuff. This must be for like somebody who goes to an honors Algebra 2 class, not where we have integrated stuff like we do here at Dresden. But anyways, Bayes' theorem, Bay was a reverend, maybe 1800s. He was a preacher, actually did a whole lot of probability, not sure why. His little theorem, I'll try and type it out, says the probability of event A given B occurs is the probability of event B given A times the actual probability of event A sitting pretty over the probability of event B. That's the thing we're going to refer to, okay? We're going to take this stuff and I'm going to make up a population here. And that's one thing you have to do with Bayes' theorem. It's actually not that bad. You just have to do it a couple of times. You have to learn to make tables. And this example, for some reason, this one is hard for me to comprehend. Anyways, I'm going to make some tables. Let's see here. We'll have to have a couple of distinct columns. Rows, I should say. Some columns. And some totals. And I'm going to make up a hypothetical population of 10,000 people. Just a big number. All right, so the virus Mathematicus extremis infects about 1 in 250 people. Now, that's a big deal. Here we're going to have some things. We have a positive test, and we also have a row that deals with negative tests. In 1,000 people, these are going to be the true results, by the way. In 1,000 people, we would fully expect that 1 in 250 would be positive. So I take 10,000, I multiply it by 250, and I should get 40. Sorry, 1 over 250. You ever have a mouth that your brain or it couldn't keep up with? That's mine. I'd expect 40 people to actually have this Mathematicus virus. The remainder, which is 10,000 minus 40, 9,960, don't have it out of a total of 10,000. Now, the test has 99.5% accuracy for both negative and positive. So let's take our 40 and multiply it by 0.995. So out of the 40 people that have it, the test would say 39.8 do, which would mean that 0.2 do not. And this is going to be positive result and negative. So let me title that column positive and this column negative. Let me clean this up a little bit so it's more readable. I'm just going to delete that line now. All right, for those that test negative, again, we have a 0.995 negativity rate too, because it's 99.5%. So 0.995 times 9960 generates 9,910.2. which means there's got to be, what, 49.8 over here on positive? So if you take all the people who should not be sick, it's going to diagnose about 50 of them as actually sick. All right. So if we add our columns together, if we do 39.8 and 49.8, we get 89.6 for a total. And if we take our negatives and add them together, even though I don't think we need this one for this problem, we get 9910.4. All right, now let's talk about Bayes' theorem. I've gotten this kind of written kind of funny, but the probability of A is actually the probability of being positive, whether it's a false positive or true negative. It's the probability of being positive, whether false, whether false or true. That's what this is about, the probability of being positive given you tested positive. So anyways, probability of being positive, whether you're false or true, is going to be 89.6 out of 10,000. Because that's how many people are in the sample. All right. And that'll give you 0.00896. All right, what's event B here? Event B is going to be the probability of the test saying we're sick. So the probability of a positive test. All right, probability of a positive test is 0.995, given that you're sick. And that should say that. Probability of positive test given sick. It's 0.995. Sorry, that's not right. That's probability of event B given A. What else do I have to find up here? I have this probability of event B. Oh, forgive me, kids. That was event B. Probability of event A is the actual probability. See, I'm already screwing this up. Bayes' theorem messes with me. Probability of event A, which is the probability of being sick, actually being sick, is given in the text. It's 1 over 250, which should be 0.004. Let me push some buttons and make sure I'm right on that real quick. I'm tired, and I am. And I think I have everything I need. I've defined B, B over A, and A. So the probability, and by the way, what they're asking for is B given A, is the probability of a positive test given sick, I think. No, a probability of being sick given a positive test. And it's not what you think. Like, they fully expect every kid who sees this to choose D, and it's not. It's never that easy. So let's plug into our little formula here. The probability of event B given A is 0.995. The probability of an actual true test is going to be 40. Hold on a second. It's going to be 40 out of sorry, is going to be 1 in 250 because that's P of A. And it's all getting divided by this probability of B, which was 0.00896. And again, I am probably murdering this. I am not a statistics teacher. I haven't taught at Bayes' theorem in 12 years, and I haven't used it since. Last time I taught Bayes' theorem was in 2012, and I have not sat down and used it since. So I am extremely rusty on it. If you happen to be a statistics teacher who's watching me, I'm sorry. I'm sorry I'm murdering this. Forgive me. I'm just an average guy who doesn't do this every day of my life. There we go. It equals 0.4442, which makes me choice B. And that's Bayes' theorem. I'm curious to see if we cover that in Algebra 2 this year. I haven't looked that far ahead. I probably should. 39 is something that we do on a regular basis. Suppose that f of x is 3x plus 2 and g of x is another linear function satisfying the properties that f of g times g of f is equal to f of g is equal to g of f. So what they're saying is f of g of x is equal to g of f of x. And you have any idea what they're telling you? They are saying g of x is the inverse. That's what they're saying. Now, they're telling you that g of 1 is 3. But we're just going to go ahead and find this thing. There's shortcuts to this. They're looking to see if a kid knows rules about inverses and stuff. And by the way, if g of 1 is 3, then f of 3 is going to be 1, which is kind of weird here. G of 1 is 3. Interesting. Oh, actually, they're giving an ordered pair that lies on G. But for f of G to be equal to G of f, they presumably have to be inverses? I'm not so certain about that. It's the only thing I'm aware of that says that. Anyways, let's find G. X would be 3y plus 2. X minus 2 equals 3y. X over 3 minus 2/3 is y. And is this true? If I plug in a 1, what do I get? Ah. Huh. That didn't work. If I plug in a 1, I'm supposed to get a 3 back. All right. That stinks. I was basing my train of thought based on f of g of x equaling g of f of x equaling x, which means they're inverses. They obviously, this is not what they want. Let me pause this and think for a moment. All right, so I'm going to go with my gut feeling. And my gut says the slope needs to be negative 1/3. And they gave me this. So what they gave me is I have an ordered pair. X is 1, y is 3. I'm just going to do some point slope form here. Y minus 3 equals negative 1/3 x minus 1. Y minus 3 equals negative 1/3 x plus 1/3. And if I add 3 to both sides, I'd have negative 1/3 x plus what? 4/3? Not 4/3, 10/3. So let's see if this actually works out or not. All right. Let's see what happens when we do a composition. And does this actually make sense? If I plug in a 1, yeah, I get 3 back. All right, so let's check that out. Let's do f of g of x f of g of x is going to be 3 times negative 1/3 x plus 10/3, and then plus 2, which is going to be negative x plus 3 plus 2. G of f of x is going to be negative 1/3. There's an x. She gets replaced with 3x plus 2, and then plus 10/3. So isn't looking too bad. I don't think it's the same though. It's going to give me negative x minus 2/3 plus 10/3. Ah, phooey. Those are not the same, are they? Boy, that stinks. I was hoping for the same thing. So I am wasting some of your time here, but the technique I'm approaching at's eventually going to get the answer. I'm sorry, it's going to be a tedious trial and error technique. So my gut was wrong, as you can see. I'm also doing some very bad math here. That should be 10. But my gut was wrong. It happens. So let's try a different number. And let me pause this real quick so I don't waste your time. All right, so good news. That only took me a few seconds to figure out the right one. So we're going to go with this one right here. And just for that matter, just to make sure I'm right, let's check against the key. 39. Algebra 2. We apparently disagree. They're saying it's D. Huh. Maybe I didn't have it. So let's see what they're saying. They say it's this one. Let's do the same thing we've kind of been doing. We're going to use point slope form. Y minus 3 equals negative 3 times x minus 1. Y minus 3 equals negative 3x plus 3. So y is simply negative 3x plus 6. Now let's do our composition here. F of g of x would be 3 times negative 3x plus a 6, and then plus a 2, which is going to be negative 9x plus 20. And g of f of x is equal to a negative 3 times 3x plus 2, and then plus a 6. Yeah, see, here's another one of those I think they've keyed out incorrectly. I really think they're keying some things out wrong. Here's something that actually happens. And I'm pretty sure they do this on purpose. They don't answer things correctly. I think that doesn't come out until later. And I don't see a mistake that I would have made. So anyways, this is not going to be the same thing. I'm going to get the negative 9x. And that's it. They're not the same. So this one was definitely keyed wrong. It's not choice B. I came up with choice 2. Undo. All right. So let me plug a 2 in because it's talking about the slope. Y minus 3 equals 2 times x minus 1. Y minus 3 equals 2x minus 2. Y is equal to 2x plus 1. All right, do my composition. I need f of g of x. That's going to be a 3 times 2x plus a 1 plus a 2, which is 6x plus 5. Do g of f of x. That's going to be 2 times 3x plus 2 plus 1, which is also 6x plus 5. So if you are home, looking at the key, it is wrong. Correct answer is D. And I'm looking at the key right now, and it says B, which is wrong. That happens. All right, 4.